Hello again, this is Mark Summers from Summers Technical Services. We're going to continue on with our RF chassis project. I showed you how to set up the product structure with the -10, -30, -50 assemblies and how to roll those up into the top level assembly, and also place some components based on their interconnect diagram supplied in the parts list. And so I want to go into a little bit more details of how to locate connectors on the front and rear panels, and then eventually we'll do the cutouts for those connectors, and then finally do a little quick video on the -50 DIN rail. So let's get started. All right, here's my attempt at starting my design. I plopped in a chassis, some height, some depth, and maybe that'll change, maybe not, but it seems like everything fits reasonably well. And I got my fans in there, and so I need to start adding some components to these front and rear panels. And so the first thing I want to do is go grab my interconnect diagram. We'll drag that over here, and I want to put some connectors on the front panel. There's one called J1 and there's one called J24 and everything between. So I need to go find on my parts list what in the world that is. And so I'll go to my parts list and drag this over here, and notice that there's J1 through J24 right there. And I know the part number is going to be that number right there. And I can look up the data sheet on the manufacturer's website by using that cage code search we talked about before. I gave you all the data sheets, so hopefully they're updated, but if they change, you always want to go to the manufacturer's website to get their real current information. So PE9184, so I'm going to go component, insert components, and go browse, and I don't want to go there. I want to go into my models. I want to go to components, and I notice there's several different PE9184 parts, but I want the assembly because the assembly is going to roll all those in. So there it is right there. I'll open that up and just plop it on the screen. First thing I'll notice is it's backwards. We want that nice outside facing cylindrical feature on the outside, not the inside. So we can fix that. So let's place this thing. I want to go face. I want to select that face and control click the front face of the panel. Hit mate and watch it move over slowly, but it's still going to move over, hopefully. I got my hourglass here. Alright, and I want to flip it, and then I'm happy. Alright, so now I can constrain it in X and Y, but I really don't know where it goes, where it's going to end up going. So I'm just going to drag it up here and make me a linear pattern. So I'm going to pre-select the assembly component I just placed. I'm going to go to linear component pattern, and I want to pick a couple of directions. I like to use the planes because they're always going to be there for me. So I'll go in that direction, perpendicular to the right plane, direction 2. Let's go perpendicular to the top plane, and I don't know, pick a number. And we got to have 24 of them, so maybe I could do 2x12 or 3x8 or 1x24. And so just try something and see how it works out. So maybe I'll space these at 3. So that's 3 times 8, that's 24. That'll give me what I need. And it's going the wrong way in the Y direction, so I just flip it and say OK. And it's not horrible, but it's obviously not good. I got too much of a spacing this way. You want to get them close together, but don't get them too close, where you want to be able to have the assembler be able to get their fingers in there and get their wrenches in there and tighten these things up. So get them close, but not too close. Excuse me. All right, so now I'll leave that to you. Let's do the same thing on the rear panel. Let's throw something on the rear panel. Let's go back to our interconnect diagram, which is the key to the world. And on the rear panel, What is this J? Let's do one of these signal power and control connectors. So what is J30? Let's put J30 on there. So J30 happens to be on my parts list, hopefully. J30 is somewhere right here. There's J30. And it's an amp connector. I recognize the cage code. You will too after you do this for a while. So I got a 207 part number, so let's place it. Looks like probably it right there. Oh yeah, that's one of my favorite connectors. D sub, you can count the number of pins. D sub connector, how many pins was that? Kind of curious now. Where's the parts list? 25 pin. 25 pin connector. These are super common, and I love them because AMP has great data sheets and they're high quality, and I don't care what they cost, they're worth it. Alright, so let's mount this thing. This thing needs to be on the outside. That's the outside face. So this thing needs to flip around. And I want to mount it such that the cable stays on the inside of the chassis. And so I'm going to mount this face right here to this face right here, mate. And then I need to flip it like I did the other one. And it gets on this crazy angle, but who cares? We're going to fix that later. So I think that's what I want. Yes, it is. It's going to stick through that way. That way, that connector, when the connector needs to be replaced, the cable, there's going to be pins, there's going to be wires coming out of this thing, 25 of them, connecting to our dash 50 DIN rail and to who knows what. And so we need to make sure that we can pull this thing out from the inside. So that's why it's called a rear panel mount. Alright, so maybe I need one more mate to get this thing so it's in the right direction. Here it is here. And I'll grab the top plane. Notice I put these planes in beautiful logical locations. And we'll mate that to the top plane of the dash 10. Whoops, that's the dash 30. Let's find the dash 10. There's the top plane of the dash 10. Uh-oh, we got the hourglass going. Thumb twiddling time. Alright, there's the top plane of the dash 10. The dash 10 tells that connector where to go. And so I want to use that plane, and there's a top plane of the connector mate. Alright, so now it's oriented correctly. Alright, now it's time to do some cutouts. And so we're not going to do the cutouts. You're not going to select this front panel and activate it and cut in that front panel. We do not want to monkey with the Tecmar chassis, the parts or the assembly, because we buy that and leave it just like it is. That's the whole reason we made this dash 30. So I'm going to activate the dash 30, right click, edit assembly, and what it's going to do is it's going to leave me in the dash 10 assembly. See, it's still dash 10 assembly, but right now I'm editing the dash 30 subassembly. And you can tell that by the fact that this is all blue here. And this edit component button is pushed in. And so this is how you do top-down designs. You don't monkey around with opening up individual parts and assemblies because you can't see the rest of the assembly. You want to do a top-down design, you want to see everything all the time. So right now I'm editing the dash 30. I want to make a cutout in this front panel for this connector. And so let's go find the data sheet. And if I go to here and go to, where did I give it to you? Handouts? Yeah, here we go. So where's the 207? There's AMP cutouts. I think AMP got bought out by Tyco, but there we go. Alright, so here's, whoop, I don't want that one. That's the second one. The first one is this guy right here. You always go to the manufacturer's data sheet, because who better to ask how to mount their part other than the manufacturer. Alright, here we go. View, rotate. Alright, so here's the connector. Here's all the dimensions. I don't need the dimensions because Summers has already gave me a model. He's already done all the hard work. All I need to do is make this feature right here. And so if I make that feature in my front panel, the connector will perform as specified by the manufacturer. And that's what I want. I don't want to guess at what size hole. I don't want to measure the connector and try to figure out what hole. This is what the manufacturer says is required to make this part function as designed. So I want to do what they tell me to do. All right, so we're in this thing. I want to go sketch. I want to select this face here, and I'm going to sketch. I'm sketching in the dash 30 assembly because it's highlighted blue. All right, now what do I need to do? I need to draw that cutout. Someone draw a circle somewhere, and I want to draw a line. Right click select to get out of the command. Maybe do some trimming with my lovely power trim. And get out of here. This thing here needs to go vertical. I'm getting close. I want to say okay. Now I'm going to go to dimension. Why did I push that button? I want to go to dimension. I've got 0.3 from here to here. And I notice it didn't grab the arc like I asked, but I can fix that by selecting the dimension and doing like we did on an earlier assignment. Come down here and I want to go to max. So that's the dimension I want. Got to change the number now to 0.3. And I need to add a dimension for this diameter. And it's trying to give me a radius now. I'm going to fix that in a minute. So right now I'll type in 0.33 divided by 2. What happened to my size here? Let's get this thing back full screen. Where's my mouse? There it is. Boom. Alright, so I don't like this being a... Get out of that smart dimension command. I don't like that being a radius, but I bet I can change that if I poke around here for a minute. So there's the properties of that dimension, and boom, that makes it a diameter. So those numbers match exactly what the data sheet says. So anybody that comes back in 3 days or 3 months or 3 years can look at this and say, okay, I see what Summers did. He actually looked at the data sheet. Now we need to locate, excuse me, we need to locate where this connector is relative to the origin of the dash 30 assembly. And so if these are going to be 2-inch spaced, then, and they're symmetric, then what's the distance from here to here? Well, it's going to be 1, 2, 3, 4, 5, 6, 7. So let's put that dimension in there. From here to the origin, that's going to be 7 inches. That'll keep that thing symmetric left to right based on my pattern I did earlier. All right, what about up and down? Well, I don't know. I gotta choose something and then maybe we'll adjust it later, maybe not. So let's maybe make this here to here. What's going on here? I gotta get my smart dimension first. Let's go here to here. And I don't know, we can make it 1. Make it whatever you want. But I like to have these locations all from the same common location, which are the XYZ front, right, top planes of the dash 30 assembly. So that's fully defined, which is a good thing. So I'll get out of the sketch. And now the magic's going to happen. I don't want these connectors to be located from planes and things. I want that cutout, that D-hole, as opposed to an A-hole. That D-hole needs to tell that connector where to go, because that's what happens in the real world. You put that feature in there and you grab the connector and you plop it into the D-hole. And so I want this connector to follow that D-hole. We'll do that in a minute. Before we do that, we've got to turn this sketch into a cut. So I'm going to select the sketch. I want to go to, where's the feature tab? The feature tab is gone because I'm in an assembly model, but we can still get there. Go to Insert, Assembly Feature, Cut, Extrude. All those feature commands that used to be on there when we were on a part aren't showing up on the tree because it doesn't make sense to show them on an assembly model. But we can still get to them. Insert, Assembly Feature, Cut, Extrude. And we want that thing to go through all. And we say OK. And then we say, yeah, rebuild it. There we go. So what happens? Well, it's good and bad. That looks really good, but that looks really bad. It went through the whole freaking chassis, the Dash 30 chassis. And so I can fix that. Right-click, Edit Feature. There's a box down here that says, what do you want it to go through? And right now, it's guessed that I want it to go through. Let me drag this over. It's guessing I want to go through the... I can get to the end here. There's a front panel and there's a rear panel. I don't want it to go through the rear panel. It guessed wrong. So I want to right-click and delete that selection. And now it's just going to go through the front panel. So you have to keep an eye on that option to make sure it doesn't cut through more than what you bargained for. So now it's behaving correctly. Now I want to do a linear pattern of that feature, which I can do now because I am in the Dash 30 assembly, and this feature pattern, this linear pattern, will show up in the Dash 30. So I want to pre-select that cut extrude we just did. And again, I got no feature buttons, but I'm cool with that. I can go Insert, Assembly Feature, Linear Pattern. They're all there. You just got to go find them. And I'm going to do the same thing I did with the component pattern. Direction 1, I'm going to choose the right plane of the Dash 30. Right there. And for the second direction, I'll use the top plane. And the distance is going to be, what did I say, 2 inches. 80 of them, that's too many. I want 8 of them. That looks reasonable. And now the other way, I think I had 3 inches before. That seemed like too much. Let's do 2 inches and 3 and see if that looks any better. Oops, going the wrong way. I'll flip the direction. It's still too much. Let's make it 1 inch. Oh, now we're rocking and rolling. That looks decent right there. And so that pattern looks better than the component pattern. So I'll say OK. And yeah, we'll rebuild. Always rebuild. All right. So now my Dash 30 is golden. I want to go back out. And so I can get out of the Dash 30 and go back to the Dash 10 if I click this button here to get out of the Edit Component. Or I can click this button here to take me back. Either one of those buttons does the exact same thing. Now I'm back in the Dash 10. Now I'm going to do something weird, or it seems weird, but hang with me here. I'm going to get rid of this pattern I made. So I made this pattern that looked kind of cool, but I want to get rid of it because I want the pattern to be driven by these features, not by some number I typed in. So I'm going to kill this guy. And I'm also going to start adding, I want to add some more make constraints so that this cutout tells this connector where to go. And so right now I've got one constraint on this guy. It was loose. I could drag it around, but it stayed on that face. So that constraint stays the same. And so what I want to do is drag him over here. This D-hole makes this thing so this part doesn't rotate. And if you zoom in here, there's a flat spot on here somewhere. There it is right there. That flat right there is what sits against this flat over here and keeps this thing from spinning when you tighten up the nut. So I grab that flat face on that guy. I'm going to come over here and control click this flat face. If I can find it. When it's transparent, sometimes it's hard to see. It's that face right there. And I want to mate. And it's going to guess I want it concentric. But I don't want it concentric because it's not touching it. It's just parallel to it. Someone change that to parallel. Okay, okay. And now I need to line up these cylindrical features, and that should be the last one. So I can grab any of these cylindrical features. That one right there is handy. And again, I've got to spin this around. You might have to turn that transparency off to make it easier to select. All right, boom. That thing can't move. That hole, that D hole, is telling that connector where to go. All right, I got to pause a minute. This is where it gets crazy good. This is where I get goosebumps. Okay, so hang with me. I'm going to drive the pattern of this connector based on the pattern of the features. Because if I change the pattern of these features, I want the connectors to follow. That's what happens in the real world. So this is the goosebump time. There it is right there. Whoops. There's the part. And I'm going to come up here and I'm going to pull down this linear component pattern. I want something different. I want this guy right here. Pattern driven component pattern. That's the perfect name for it, because that component pattern is driven by a pattern, a linear pattern on a part. Pattern driven component pattern. I've already pre-selected that assembly of that connector. And let's see what it's going to ask me for. It's going to ask me for, what do you want a pattern? Well, I've already pre-selected it. And it says driving feature, and I just select one of these guys. Boom. It just follows a pattern. If I omit one of those cutouts, the connector won't be there, because I'm telling the connector to follow that pattern of the component linear pattern. Pattern-driven component pattern. All right, some of these you'll do this with. Some of them you only got one connector. You'll just make the cutout and be done with it. So put all the connectors on the front panel, put all the connectors on the rear panel, and the next step is to, what are we going to do next? Where's my list? We did the cutouts, panel cutouts. Oh, we need to do the dash 50 DIN rail. All right, so we'll pause this here. Get these cutouts done in your dash 30. Make sure you're activated the dash 30. Otherwise, it'll be a big disaster. You have to change it later, and you have to redo everything. So ask me if you got any questions. Otherwise, we'll see you in the next video. And until then, this is Mark Summers from Summers Technical Services.